So the purpose of this lesson today is to talk about some special methods, to give you another example of how to create your own class. Well, I mean, today we're going to actually, hopefully, do 3 different classes, and to have the classes interact with each other. That'll be the purpose of the very last video. So video 1, we'll do card and sort of what that's supposed to look like. Video 2, we'll do a deck and create sort of what that's supposed to look like. And then video 3, we'll do a hand. So let me just give you what I think a UML description of what a card should look like, at least for the purposes of what we're designing it for. These are the you'll see like a blackjack hand, BJ hand value. BJ value is the value of a card in blackjack. In value. We're going to ordinally, put cards from 2 to 15. A suit is the spades, clubs, hearts, diamonds, and then and you can kind of see what the attributes of the card is. These 1, 2, 3, 4, 5, and then we're going to create a get suit. So if I want to know what the suit is, we'll do that. We'll figure out how to create a method that does that. And these are sort of the methods, right? These are special methods, but they get the 2 underscores on them. And then we'll develop all that. So I will pull this up every now and then to figure out kind of where we're going, but just know that that's the idea anyway. Okay, so what does a card look like? So I've already imported NumPy. I'm going to bring in a class card, and it's going to be an object. And the very first thing that we want to do is do the init. Right, our constructor method, and then self comma C. And well, what is C? C is going to be sort of an input string, and that's all we need. So let's see, FV face value is just a list, and we're going to let that be 2, 3, 4, 5, 6, 7, 8, 9. And instead of the number 10, because it has a 1 and a 0, I'm going to use T. So that's a 10, a jack, a queen, a king, and an ace. So that's going to be our face value. Face value of 8, right? So what is 8? 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, 0, 1, 2. So you come and you'll see that it's 10, and I want that to be a 10. So basically what we did was we created this. So this is just a list of 2, 3 through ace, and then we changed the 8th one to be a 10. And then change. So what is NV? Actually, it should be numerical value. So NVAL. Let me make sure I'm getting all this. So FVAL, FVAL, FVAL. Range, and we want to go from 2 to 15. And the reason why we start at 2 is because I want it to line up. So in other words, like a numerical value for 5 should be the number 5. For 10 should be 10. And then when we start ordinally rank these things, jack obviously is the one after the 10. So we're going to let that be 11, and then 12, 13, 14. And then why is it 15? Let me see. Did I say 15 on here? I did say 15 on here. What I really meant was 14, because the ace is going to be given a value of 14, because we know that goes to n minus 1. So that's nval. Let me pull this sucker back up. Let's see. So what else do we need to do here? So if C, sorry, the length of C to 2, then self dot f val. Yeah, maybe we do keep this. Redefining this thing in here. So NV, so f val is equal to C of 0, and then C self val is equal to C0, and then if self dot fval is equal to 10. So this would be, so fval equals to e, then we want to say self dot f is equal to the number 10. So what are we doing here? So first of all, you're looking and saying, okay, if I have two numbers that are coming in, like 10 of spades, so what we're assuming is the C, the first thing in that the first letter in the two-letter sort of combination corresponds to either the number that the card is, right? So if it's a T, then we know we want to assign that to a 10. And then suit or self.suit is equal to, it should be a C1, right? So it's the second letter in there. Then if it came in as 3, like somebody actually put in 10, so L if length of C is really equal to 3, we're going to assume that it was a 10, somebody used 1 0, and then self you see 1 0, what is that, 0 to 2, I believe, because it's n minus 1, and then self dot suit will be equal to the third, or the third number really, but the second one, the 2 index. All right, else. Anything else, I'm just going to assign it some arbitrary value. So I'm going to say the face value is equal to 2, and I'm going to say that suit is equal to spades. So I'm going to let it be 2 of spades. Again, very, very arbitrary, but I'm going to also print, maybe I'm going to let the user know not correct format for the object that we created. I didn't want it to be not equal anything, but I also wanted to we also had to let the user know that they did something wrong. So inval, so numerical value. Let me pull that up real quick. Inval is numerical ordinal value from 2 to 15, right? So if you do that, so inval equals to nv, right? I'm going to index in fv dot index, then self dot. So what is that doing? Self.fval right now is a string, so it's some string between 2 and ace, also being the 10. So that's a list of numbers, and then I'm going to index into that list of numbers. I'm going to pull out whatever fval is, and that's going to be the index into that, and then I'm going to go to nv, right? What is nv? It's just numbers from 2 to 15. So that's all we're doing. So we're going into this range of numbers between 2 and 14 actually, and going to pass that out as the inval. So these 3 things up here were just so that I could pull out that information out of the list. All right, so we got self dot bj_val equal to, let's see, what do we want bj_val? So I want it to be 10 if self dot inval, so the numerical value is greater than or equal to 10. Self. Right, so think about what this does for a second. So it sets bj value equal to 10 if I'm greater than or equal to 10, and then otherwise it just sets it to whatever the current inval is, right? So the current inval is whatever numerical value between 2 and 14, right? So that's what it's doing. So the only thing that's wrong about this statement is that if it is an ace. So now I got to go back in and correct that. So if self dot, well, how do we know if it's an ace? Again, this thing goes to 14. 14 will be lined up with ace. So if inval is equal to 14, this is one way of finding it. Obviously, we could have checked the fval equal to a. Self dot bjval is going to be equal to 11. Okay, so I think we've done the bjval, we've done inval, suit, rank. Okay, so now the last thing that I want to do is I want to rank all of the suits, and I'm going to let spades be lower than clubs be lower. So diamonds is my highest thing, and spades is the lowest. So I'm going to rank all of the cards from 1 to n, basically. And the way we'll do that is, I don't know, let's say suit, let's say S is equal to list, and then we'll say spades, clubs, hearts, diamonds, I believe is what we said. Spades, clubs, hearts, diamonds, yep. And then, let's see, rank equals to S dot index. So self dot suit is equal to that last letter in C. So it's either spades, club. It should be either an S, C, H, or D. So I should probably do a try except here, but I'm going to assume that the user's putting in a spades, clubs, hearts, and diamonds. Again, if I was trying to write this thing for a real user or someone I didn't know, I would definitely do a try except here, just to make sure that that my suit actually is in this area. So we got suit rank is equal to that. So self dot rank, I believe is what we called it. Let me make sure. So I'm going to rank it, and then self dot rank is equal to suit rank times 13 plus. So what am I doing here for the 0th one? It'll multiply by 0, and then it'll just add up, from 0 to, or I'm sorry, from 2 to 14. And then it'll jump to the next one, and it'll multiply by 13, and then hopefully it'll add, and it'll be something different. In other words, I want the 2 of clubs to be higher than the ace of spades, and hopefully that does that. But we'll test it out in a few. So that's I think that's all we need for our constructor method. I don't really return anything in it. I won't worry about that, because all that's doing is just setting all the things equal. So the next thing that we want to do is what? So representation, right? So what do we want it to look like when we hit return on it? So underscore REPR, and then I'm going to pass in self, because that's the only thing that we need to see what this thing looks like. And result is equal to space, and then result plus equals self dot fval plus self suit, I believe is all we need to have happen. So I'm going to add those two together, and I'm going to return result. All right, so that'll be what we want it to look like. So just give me the fval. So in other words, the 10, it would be at 1 0, and then the suit, whatever the suit is. All right, so that's what we're going to do there. And then let's see here. Do we want to do a string? REPR. Maybe we want it to look a little different. Oh, yeah, we could just say, if we want it to look exactly the same, def self. Could literally like just pass in the same stuff here. I don't think we're going to want it to look any different if I typecast it. I know I didn't have it in there, so I just kind of at the last second said, you know what, I'm going to put a string. What happens when it typecasts or I do a print? The next ones are, I don't know, def underscore less than. So how do I know if one card is less than another? So if I'm comparing two card objects, this special method would tell me what to do. And I'm just going to return self.rank is less than what is it, other dot rank. So what you're saying is I'm going to have on both sides of this less than sign, I'm going to have a card type, and if that's the case, then it's going to go to this thing and say, well, what tells you which one's smaller than the other one. So def greater than, oops, I forgot the underscore greater than underscore self comma other, and I'm going to return self dot rank is greater than other. That's how we're telling them different. Let's see what happened. What's the next thing? Just make sure I hit everything. Subtraction. Subtract 2 cards, return the difference. Okay, so what do we want to have happen when we subtract 2 of these? Underscore subtract off comma other. All right, so if I had 2 card objects with a minus sign in between them, what do we want it to do? I want it to return self dot rank minus self or other dot rank. I think we'll be good there. And what's the last? Let me just make sure I hit everything equal. So how do we know if 2 cards are equal? Def equal self comma other return self dot rank. So we're doing everything based on this rank. You could definitely like compare face value and suit value, but I mean, since I have this rank thing already in the object, I might as well use it. And then if we want to do, I think we just want to do a get suit. Yeah, so the get suit is one thing I haven't done yet. So it's right there. Move this so it's back in the spot. So get suit returns the suit value. So this is not a special method. It's just a method that we created. Get suit self. Pass in self. You're going to return self dot suit is what we called it. Self dot suit. Yes. Okay. Easy money. I think that's it as far as the card object goes. Let's sort of test it a little bit. Hit shift enter, and let's go with C1 is equal to card. What did I say? It's ace of spades. C2 is going to be equal to card spades clubs. So clubs will be the next one. 2 of clubs. FV is not defined. Where did I mess that up? FV equals this list. Where's it telling me? Self.nj. FV. Is that a capital V? Hopefully that's not a capital V. Is a capital V. Go ahead. Sorry. And then here, shift enter again. Built-in function is not subscriptable. Oh, what am I doing there? It should be index. It should not be. Yeah, that should be it. This is a method. I apologize again. Sometimes it takes the little guy to tell me, right? FV is a list. It has a method called index, and you can't subscript a method. It doesn't make any sense. So let's do that. So print. So if I printed C1, it's going to give me the same one as if I did C1, C2, print C2. And if we wanted something different for print versus just hitting return, we would have to do something. So now I'm going to, is C1 equal to C2? Whoa, C1 is equal to C2, or should be returning. All right, so let's look at the ranks, because apparently C1 dot rank, C2 dot rank. All right, so that should not have been true. So why is, oh, because I got 2 self. I'm a knucklehead again. It's going to be equal to everything, right? So let's try it again. So you get, once you change your class, you have to re-instantiate your objects. So we can do that, print, and now we get false. Okay, good. I didn't do that on purpose, but it is, I mean, you guys are going to have to work through these bugs every now and then. and you just got to make sure that that things are doing what you want it to do. Now the question is C1 less than C2? True. Let's print C1, print C2. And so ace of spades is less than 2 of clubs, and the answer is true, all because of that rank. All right, well, that's all I got for this class. Hopefully you guys got something out of this one. You see kind of how to go about doing it. If you see the UML, so if I give you something like this, you should be able to create the object that sort of does this kind of stuff. I claim that this is probably the harder of the two. Now that you're starting to think about objects and how to create them, this part that's coming up with what you want it to look like and what you want it to do is probably a little bit more difficult than even the programming piece to it. And I know I had some of these things. I'd already done it sort of in my head. Many of these things. Actually, I'd done it in the Python already. But you might have to think about how you want to do some of this. All right, that's all I got. See you next time.